Two important terms to the study of circuits is resistance and resistivity. These two terms sound very similar, but they have very different meanings. Resistance is the property of an object, whereas resistivity is the property of a material. So we may say that a resistor or an object like a pencil or an eraser has a set resistance, whereas resistivity would be a property of like maybe copper or the lead in a pencil or something of that nature. So a material, perhaps something that could be found on the periodic table. Resistance is defined by being the potential difference across an object divided by the current inside that object, whereas resistivity is defined by the electric field divided by the current density. You'll see that resistance uses a capital letter R as its symbol, whereas resistivity uses the Greek letter rho. Final difference here is the units. Resistance is measured in ohms. We see that the symbol for ohms is the Greek letter omega, whereas resistivity is in ohm meters, or that Greek letter omega times meters. So you can deduce from those units for resistivity that that there'll be some relationship here between resistance and resistivity. And that's what our next slide is about. We want to, in the end, come up with a relationship between these two quantities. So we'll use some past knowledge to do so. First of all, we know that if we have a constant electric field, the electric field can be found by finding the potential difference divided by displacement between 2 points. So potential difference between those 2 points divided by that displacement. And we also know that the definition of current density is current divided by area, or cross-sectional area. We're going to assume that the electric field is in a wire, and we're going to say that our wire has a length of L. And so we'll use these two equations to come up with an expression for resistance in terms of resistivity. For starters, we'll start with a definition of resistivity. Resistivity is the electric field divided by the current density. Electric field, I'm going to express as the potential difference divided by the length of my wire, because I'm going to go from one end to the other of the wire. So delta X becomes L, and current density is I over A. Plugging those two expressions into my equation and then just simplifying so I don't have a fraction in the denominator gives me that the potential difference times the cross-sectional area divided by current times length. Now, I could express this as potential difference divided by current times area over length. And we know that potential difference divided by current is R. On your equation sheet, this is expressed as saying the resistance is equal to the resistivity times the length of your object divided by its cross-sectional area. That equation is on your equation sheet. However, in your learning objectives, it mentions that you need to be able to derive this equation. So understanding this process of how we got from our definition of resistivity to a relationship between resistance and resistivity is important. And it's something that we'll come back to as we solve some problems in class.